Here we've got a displacement time graph. And we know from our tutorials that the slope of a displacement time graph represents your velocity. And since velocity is a vector, it has both magnitude, which is how steep the slope is, and direction, which is way it slants. So in this first region, we see a fairly shallow slope that's in the positive direction, right? Positive slopes are this way, and negative slopes are this way. So we've got a shallow positive slope originally, meaning he's walking at a constant speed in the positive direction. His initial position happened to be -3. So he's starting on the left-hand side of some defined origin, and he's walking at a constant positive velocity all the way up to 12 seconds. At 12 to 15 seconds, the slope remains flat, which is 0. So he's not moving, and it makes sense. He stays at the 6 meter mark for that span, for that 3-second span. And then from 15 seconds up to about 16.5, if we estimate, again we see a positive slope, but it's quite steep, so it's really positive. So he's going much more quickly in that region than he is in the first red region. And at the end, you can see that he starts to make his way back towards home. So he goes from a position of 12 meters back to a position of 9 meters. So he's changed direction here. And you can see that the slope is negative. But it's not very steep, so it's a small negative value. Now to calculate the slopes in each region, we simply have to do rise over run. So in the first region, make it as big as you can to avoid any rounding errors. So in the first one, I go from -3 all the way up to 6. That's a rise of 9, and the units would be meters. And the run goes from 0 to 12, that would be 12 seconds. So if I'm finding the slope of region 1 between 0 and 12 seconds, I would say my slope, which we call m, is rise over run, which is 9 meters over 12 seconds. And it's a positive slope because it's slanting from lower left to upper right. And I get a value of 0.75 meters per second. Now we already talked about the second region. The second region is flat, so the slope will just stay at 0. And in the third region, we do the same analysis. So here my rise, and there's my run. My rise goes from 6 to 12 meters. So my rise is +6. And the run is between 15 and 16.5 seconds. The run is 1.5 seconds. So this is the region between 15 to 16.5 seconds. My slope would be rise over run, and that gives us a value of 4 meters per second. And again, it's positive. Now the last region we know is a negative slope as discussed, and we'll have to get rid of some of these other values so we can see what we're doing. So let me just erase some of the clutter around it. Something like that. Let's start again. Now the last region shows a rise going from 12 down to 9. This value right here is 9. So my rise is 9. Sorry, my rise is 12 minus 9, which is 3. And my run goes from 16.5 all the way up to 24.5, which is 8. And that would be seconds. So for my final region between 16.5 seconds all the way up to 24.5 seconds, my slope is rise over run, and I get a value of 0.33 when we round properly, meters per second, and the slope is negative.